We would like to see if this function is differentiable at the x value at which the rule for the function changes. That, in this case, would be 2. That is where the rule for this function, this piecewise function, changes. In order for a function to be differentiable, it has to first be continuous. Let's start by checking for continuity. So I'm going to come over here, and we're going to check for continuity. You don't have to write all this down word for word, but this is my way of processing what's actually going on right now. So we're going to check for continuity. Well, if I have continuity, I have a few things going on. I have a function that's defined. Let's just stop right there. Is my function defined at 2? Well, yeah, it is. F of 2 is equal to, we'd plug it in, we'd get 0. Okay, great. Function is defined. I also need the limit to exist as we approach 2 from the left and the right. They have to match up. That's what it means when a limit exists. So, in this context anyway, the limit as x approaches 2 from the left of our function is equal to, let's see, if I approach 2 from the left, I'm dealing with this one. We actually just did this process in a different context. We'd plug a 2 right here. 1/2 times 2 minus 1 would give me 0. And also, let's check the limit from the right. X approaches 2 from the right of our function. And that would give me, let's see, I plug in a 2 here. I know it's not equal, but we're approaching it, not necessarily finding what the value is. But we would approach 2 from the right, and we would have 2 minus 2, which would give me 0. And so because the function is defined, the limit exists, and the limit equals the value of the function, we have continuity. Okay, I'm not going to write all that out in words, but we do have that. So we have continuity. I'm going to just put we have continuity. That's a bad way of wording it. I'm going to put the function as continuous. The function is continuous. Well, it's continuous everywhere, but it's continuous at x equals 2, which was the point in question, the x value in question. Now that we have continuity, we're going to check for differentiability. So we have this, but do we have this? Do we have one of these situations where it's bent and we don't know the slope at a specific point? Now we're going to have to use the formula that we just used, and we'll switch colors. It's for fun. I'll move this desk out of the way that you can't see. And we're going to find the limit as x approaches 2 from the left. It looks like this, but it's not. We're going to find the limit of the slope, and that is going to be f of x, 1/2 x minus 1, minus what I get when I plug 2 in from the left, which would be this piece right here. So if I plug 2 in right there, and again, you've seen this, 1/2 times 2 minus 1, there we go, all divided by x minus 2. This is the formula that we've been using. And we're going to just keep working through this, and hopefully we'll get an answer. We'll get this answer, then we'll do the one from the right. And if they're the same answer, we'll say we have differentiability because we have from the left, from the right, same slope, and we had continuity to start with. So let's keep going. We have the limit as x approaches 2 from the left. This is 0, so all that is just gone. And we're going to have 1/2 x minus 1 over x minus 2. And you might look at this and say, well, I don't know what I'm doing with this. I had to stare at it for a second myself. And actually, in every one of these situations, something's going to cancel. And it doesn't look like it does, but it's about to. So trust me. Here we go. The limit as x approaches 2 from the left. And we're going to factor a 1/2 out of the numerator. Watch this. 1/2 factors out. 1 divided by 1/2 is 2. See this? And I'm left with the limit as x approaches 2 from the left of 1/2, which is just 1/2. So the slope, you're about to smack your forehead and say, oh, I see it now. The slope of this piece is 1/2. It was a line to start with, right? So knowing what we know now, that I went through a lot of steps to find the slope, what's the slope here? It's 1. Slope is 1. We can go through that process if you want to. Do you want to? I'm going to very quickly. So let's do it again, super fast. Limit as x approaches 2 from the right of that piece of the function minus what I get when I plug a 2 in. Whoops, 2 minus 2. All over x minus 2. And that gives me, well, that's just 0. X minus 2 cancels with x minus 2, and it just gives me 1, which I knew to start with. Because the slope from the left doesn't match the slope from the right, the function is not differentiable. So given the functions below, determine if the function is differentiable. So f is not differentiable at x equals 2. It's just not. Continuous, but not differentiable.